So my name is Mark Nicholson, and I'm one of the technology managers in the ARM Central Engineering Open Source Software team. And we're going to talk about the ARM Morello platform. As per the title, the primary intent of the talk is to cover what we're doing in terms of the provision of a platform and how we're going to support it with software. It isn't a talk about the security architecture and the application of capabilities, but hopefully there'll be future talks about that. So very briefly, for people who don't already know, Morello is a prototype architecture, and it's designed to explore the idea of capabilities which are essentially pointers, 128-bit pointers, which have associated capabilities. So the pointers can have combined with them restrictions on the allowable address range or the functionality, and this restriction is supported by the hardware implementation and by the architecture. And you can apply this in different ways across the software stack, but one of the key ideas is that within a user space application, you can implement fine-grained memory protection within a process using what we call a compartment. And all this work, it is based on research originally done at Cambridge University as part of the CHERI architecture. So if you want to know more, follow the link to the developer page. So for the purpose of our talk, important point, Morello is a prototype architecture, which means that you won't be able to license it in the normal way and build commercial product. It's designed to inform the direction and the features of a future architecture. And for software, that means that we won't be adopting our usual mindset of upstreaming the support we provide, but we will maintain the support that we're developing for the lifetime of the Morello project. And there are two platforms we're creating, an FVP and a development board, and we're going to talk about the work in the software stack we're doing to support that platform. And all the work is government funded by the UKRI as part of a grant. Okay. So here, what I'm trying to do is give a very high level overview of the different work streams we're looking at down the left-hand edge. So in terms of the big platform milestones, this year, in October 2020, we have our early initial release, and that will target an FVP model, and we'll talk about what an FVP model is later. And in 2021, we should have some hardware. So ARM are developing a test chip and a development board implementing this prototype architecture. So down the left-hand edge, we have the general work streams that are going on. So we have a general platform enablement work stream within ARM. So clearly, for both platforms, we need a vanilla AArch 64 software stack port. We need to be able to bring up an operating system and to have the relevant firmware ports to run on these two platforms. And clearly, as we get nearer to hardware, there'll be a lot of work in the traditional FPGA development flow and a lot of low-level bring-up work. So all that work really is not directly to do with the Morello architecture and capabilities. It's about bringing up a generic new platform. The next work stream, and we'll talk about these later on in more detail, it is where we begin the Morello architecture enablement work. Now, ARM are not intending to completely solve the problem or deliver a solution. We're hoping to be part of a wider ecosystem effort here. And the initial work we are doing is focused on enabling people to bootstrap their own research. So we're looking at work on a tool chain, libraries, kernel development, and some limited user space examples of the application of Linaro, of capabilities. Where did Linaro come from? So Linaro comes now. So one of the important things is how we deliver the software, and we're going to be working with Linaro to work out an infrastructure to provision and maintain all these different aspects that we're working on. Okay, so let's talk in a little bit more detail about the Morello platform FVP. So FVP is a fixed virtual platform, and this is a model of a platform developed using a proprietary tool chain from ARM called Fast Models. And this will give you a relatively fast simulation of the Morello hardware. And inside ARM, we very frequently begin our software development work on FVP, as we're often ahead of the curve in terms of silicon being available, and hardware emulation platforms are obviously very slow and expensive. So we'll be working with an FVP, and the idea is that the FVP will be made available in a similar way to the current architecture VAA base FVP, in that it will be free to download and unlicensed. So if we have a look at the features in the table, so the main point to highlight with the FVP is that it will model a system that at a programmer's level and at a functional level will look very similar to the hardware. So unlike a more abstract architectural model, you will have register modeling in the CPU and the interconnect that will reflect the real hardware, and functional behavior that will reflect the real hardware. And we hope that the software stacks we provide will be very, very close for the FVP and the hardware platform. The model is relatively quick, so if you want to boot to a prompt, a kernel prompt, you're probably talking, depending on your PC, around a minute. But if you want to boot a big user space framework and a full Android, that will be significantly longer. You don't get a free lunch for a high-speed model, and therefore what you don't get is any timing or cycle count information. And we may have, or we will have, abstracted modeling of some peripheral components or third-party IP. Moving on to look at the vanilla software stack support. So when we introduce Morello capability support, it'll be incremental. So we'll be adding functionality to on top of a vanilla software stack. There won't be a big bang appearance of an entirely capability aware Android or distro environment. It'll be incremental functionality. So the starting point is to provide a standard software stack for the platform. And at a very high level, the hardware compute subsystem IP looks a bit like the box in the middle of the screen. So on a lot of ARM designs, you will have 2 blocks of compute, the main application processor compute, and a little bit of supervisory compute, a Cortex-M. And then, of course, you have the system level IP, the interconnect, the gate, media, and peripherals. And for Morello, both in the FEP and the hardware, both the interconnect and the CPUs will be enhanced to be implementations that implement the new capability functionality. So the supervisory firmware is open source firmware. The SCP firmware project is available on GitHub, and the SCP will be the first bit of compute to run out of reset, and it deals with a whole load of low-level IP initialization, so configuring the interconnect for the path to memory, but also power control and the bring up of the application compute. So over on the left-hand side, we've got a fairly traditional ARM application software stack. So we have the trusted firmware project. We're using a port of trusted firmware A at the bottom of the stack, and trusted firmware will do a lot of the Cortex-A CPU initialization and provide access to a secure runtime or service if you have one. On top of that, we have the traditional UBOOT Android flow or an EDK2 Grub Linux distro. Now, not all of this may be available at the first release, but ultimately we're working towards enabling both these environments. Right, so what are we doing to support Morello and the prototype security architecture in particular? So here are the 3 main streams of work. So we have support in the Linux kernel, the C library, and the toolchain, and all these will be maintained in forks. They will not be upstreamed. So the kernel support is all focused on the idea that if you have these new pointers, then we need a reworking of the kernel ABI and syscall interface. And in early work, so for the initial FEP release, we will be supported by a lot of functionality implemented in the Bionic C library as a shim. And as we move towards having the hardware, we should have a fuller kernel ABI. And clearly this kernel work needs to occur in synchronization with work on the C library. And therefore we have an initial work stream focused on Bionic, and the provision of a capability aware Bionic will mean that you can link an Android application against this Morello aware Bionic rather than the standard Bionic, and that will allow you to create prototype capability aware applications. As we move towards 2021, we should have work going on both on Bionic, interfacing with the generic kernel ABIs, but glibc too. And at the bottom we have the tool chain. So the early support will be LLVM focused. As we move forward, there'll be work to expand this to also include GNU GCC. So bringing that all together, here's what we're planning for 2020 and where we might get to in 2021. So the October 2020 release is supported only by an FVP model, and the software stack is really a minimum viable product, an initial release. It will be Android focused. It will be supported by the LLVM toolchain, and it will rely on the shimmed Bionic library that we've talked about with support for static linkage. We will provide a couple of example components that have been ported. So we will rebuild logd, maybe the service manager, using the new Morello aware compiler. So these things will run with 128-bit pointers, and they will be linked against the Bionic C library. And we will provide a basic compartment manager example showing a dummy application that you can segregate into a manager and different compartments within that application, giving an idea of a starting point for how to implement the support that the architecture provides. The expectation is that most people will work on a config we call Nano Android. That's a stripped down headless version of Android that will boot very quickly on the model. In theory, you can support a full Android GUI, but that will be a more difficult framework to work in. As we move on to 2021, hopefully the support will get more mature. So we have the evolution of the kernel, the library, and the tool chain we've been talking about. But the idea is that we will be able to provide not only Android, but an initial distro with the same kind of basic platform enablement, on top of which we have a number of starting features for capability aware development. So a C library and examples. Graphics support is an interesting topic. The board will have support both for PCIe, so plug-in cards, and onboard graphics, and we're looking at different options for graphical support at the moment. So another part of the picture we want to talk about is how we'll provide Morello software to people. So ARM are working with Linaro to do this, and the idea is that all the software will be available via open source projects, and that will work with Linaro to provide infrastructure to deliver and maintain the software for the life of the project. So we'll need public code repositories for the components, particularly the forked components, the tool chains, the kernel, the C library work we've been talking about. And we'll need issue tracking and tools for managing submissions. As I keep referring back to, the intention is that ultimately it will be a collaborative engagement. And of course, if we are forking software projects, then we will have to maintain them going forward. So rather than having only ports in individual repos like SCP, trusted firmware, the kernel, fork. The idea is that we will also provide a tested platform repository where we bring all these components together and have a tagged integrated release. So the idea is that we will maintain a manifest or a Yocto recipe for the different stack configurations, and we will provide a tagged release of all the components that are tested and integrated together as a complete stack, and that will provide instructions on how people can download and configure a workspace and get that stack booting quickly, to enable them to focus on the work that they're actually interested in doing. So one other point to mention is the work that is going on in Cambridge University. So I've been talking about the work that ARM are focused on. There is parallel work that has been going on for quite a while in Cambridge University around CHERI generally, and they have DARPA funding for their own work, and they will be targeting a free BSD port at both the FEP and the hardware. So this work is being managed directly by the University of Cambridge, but is definitely an alternative option for people interested in the Morello architecture.
Hi, Mark. This is just to say you've got about 3 more minutes. Just a reminder. And you've had a bunch of questions, but if...
Right.
Oh.
Well, that's good.
Excellent. You read
that's
my
good,
mind.
because that was my final slide. So if people do have questions, I can try and help.
Okay, so let me read them out to you. So the first one is, why can't we use QEMU for modeling Morello?
So I think I don't think there's a complete answer to that question in terms of a definitive you can't, but I think partly it's to do with the level of abstraction that the technologies normally model at. So with the FEP, we're targeting quite a low level CPU implementation model and interconnect model, and that work has to be done at a very early stage when aligned with the work that the hardware IP teams are doing. So ultimately, maybe you could initially, to align with the early development work, it will be FEP.
Okay, great. And then we've got another question. Will the FEP package be available with FPGA bitstream design as well, or will that be all soft EMU?
Ooh, sorry, I'm not. Can I see the question directly? I'm not sure I even understand that one. Will the FEP be available with? Where
was it? Oh, hang on. Will the FP? So if you look at the chat, you can see it. Will the FEP package be available with FPGA bitstream / design as well, or will that be all soft EMU?
Okay, so I think I get it now. So there is no FPGA. So there's an FEP and there's a test chip ultimately on a development board. So there's either a fixed hardware implementation, a dev board, or an FEP, which is a fixed binary that models the implementation that you can run.
Okay. See, we've got another minute or so. So 2 more questions. Is Morello architecture targeting a specific class of application like mobile phone, or is it generic and able to address industrial automotive application
So
terms?
it's intended to be generic. So it's actually based on the architecture of an existing ARM platform, which happens to be an infrastructure platform. But that's more for practical reasons. The idea is that we have an application CPU, and the idea that we have Android and distro is speaking to the idea that you could explore the security architecture for a number of different markets.
Okay, great. And then I'll go with one more question. So how different is the philosophy of compartments from ARM Trust Zone?
Oh, that's a big question.
Sounds like a big
it's that's quite a big question. It's a different kind of approach to security. I think the best way to answer that question is to follow the link on developer and read. And very quickly, the final question is, yes, the FVPs are basically a system that we have built using the fast models technology.